2019 question 2. The setup of an experiment is shown below, and you're given the diagram. What can be observed after the circuit is closed for a period of time? Okay, so first off, we have on the left here, we have P, which has sodium dichromate. And on the right, you have, let me perhaps underline it for you, sodium dichromate. On the right, you have, which is under Q, potassium permanganate, which is in solid form as well. And you have a filter paper, which will be eventually moistened with X. But before that, let's look at what X is actually. So you'll be given that X could either be dilute sulfuric acid, or you'll be given that X is ethanol. Now, for this circuit to work, obviously you would need something that conducts electricity. And you should have learned about the concept of electrolyte, where you need some mobile ions present in this case. So among these two, which one do you think does not have mobile ions? So obviously, for A and B, we're using dilute sulfuric acid. These definitely have mobile ions, no matter what, because you have hydrogen ions and sulfate ions, or obviously hydroxide ions as well. But how about for ethanol? Ethanol is an organic compound. You'll learn more about this in Book 3 and Book 3b. It does not have any mobile ions. There are no mobile ions here. So if it has no mobile ions, do you think the circuit would work? Of course not, it won't work. So actually, you can already rule out C and D. Now, A and B, we have now solved the problem of the filter paper. What X is, we know it's dilute sulfuric acid. Now let's look at what we can do. Now it's in solid form. Now, obviously, after you've moistened the filter paper with the electrolyte, which is dilute sulfuric acid, now they'll become ions over here as well. Now let me go ahead and see what type of ions are formed. Now on the left-hand side over here, we have sodium dichromate. Okay, so to make things simple, let me rub this out a bit. Here, what two ions are present here? If it's in aqueous form, obviously I would have sodium ion, and the other one would be dichromate ion. Now the reason why I've originally the color was orange there was because dichromate ion, they're actually orange in color. Okay, and you'll learn more about these type of ions in Book 2b, redox reactions. And on the other end here, which is Q, on the Q side, you have potassium ion. Okay, with just one point, the reason why I'm using black, there's no reason why I'm using black. It's not because sodium ion and potassium ion are black in color. They're not. They're just colorless ions. Okay, and I have MnO4 minus, which is permanganate ion. This is purple in color, and that was why originally I had purple color underlined here. Now the concept is very simple here. I have a question. Which end is the positive end? If I were to draw, which end would be the negative end? Which end would be the positive end over here? So one technique to do or to solve it every single time is the longer end is the positive end, always. And you can even check it out like this. Just draw a plus sign on it and pretty much you're done with it. So the longer end is always the positive end. Okay, the shorter one would be the negative end. Okay, now let me just bring it down over here. So above P, I'm going to write the positive end. Above Q, I'm going to write the negative end. Now the logic is very simple. Now towards the positive end, which is the P side here, what type of ions would be attracted there? Do you think the negative ions would be attracted, or the positive ions? Yep, it would be the negative ions. So the negative ions, which is dichromate ion here and permanganate ions here, they would be migrated towards the positive end. They would move towards the positive end. So here, obviously, permanganate ion would have to come from Q and then go all the way to P, and dichromate ions will just remain there. That's the logic. It's just that simple. And on the other hand, if I were to say what ions would be attracted towards Q over here, which is the negative end, obviously it will be the positive ions, which is the potassium ion here and and the sodium ion here. Okay, so these two. So now that we know the logic, what's going on, everything, now let's answer the question. What can be observed after the circuit is closed for a period of time? If X is dilute sulfuric acid, a purple patch migrates towards P. Does that make sense? Now let's look at what's the purple patch. Obviously, the purple patch here is talking about our permanganate ion because it's purple in color. And you can see it's going to it's going to migrate towards P. So, yep, this makes sense. This makes perfect sense. So, A is the answer, but let's look at option B. If X is disulfuric acid, an orange patch migrates towards Q. Nope, that's not true because it's going to remain at P. The orange patch, which is talking about dichromate ion here, it's going to remain at P. So that's the logic. So at the end of the day, negative ions would be attracted towards the positive end. Positive ions would be attracted towards the negative end. So this question answer is A.